A shocking discovery. You wake up one morning to the headline that feels almost impossible. NASA has discovered a huge hole in the sun's atmosphere. At first glance, it sounds like science fiction, like a plot ripped from an old 1950s pulp magazine about cosmic disasters. A hole in the sun? Isn't the sun supposed to be solid, unbreakable, eternal? Humanity has lived under its light for thousands of years, trusting its warmth to rise every morning without fail. And now, suddenly, the news is telling you that it has holes. It's the kind of story that makes you stop scrolling, with the kind that doesn't just spark curiosity, but ignites a flicker of unease deep inside you. Because if there are holes in the very star that keeps us alive, what does that mean for you, for Earth, for the fragile systems that depend on the sun's constant glow? But before fear takes over, let's step back. Because the truth of this story is not what the dramatic headlines want you to think. Yes, NASA has found something extraordinary. Yes, it's real. But no, the sun isn't collapsing, it isn't broken, and it's not about to suck Earth into some cosmic abyss. The reality is stranger, subtler, and in many ways, even more awe inspiring. You see, the sun is not just a ball of fire, as you might have imagined as a child. It's a churning, roaring sphere of plasma, with an atmosphere more dynamic and mysterious than Earth's sky on the stormiest day. For centuries, you and I looked at it from Earth and saw only a perfect golden disk, radiant and unchanging. But modern instruments have revealed that its atmosphere is alive, pulsing, twisting, and sometimes thinning out in vast patches that appear as holes. NASA calls these regions coronal holes, and when one was spotted stretching across the sun's surface, wide enough to engulf dozens of Earths, it shocked even seasoned solar scientists. Through the lenses of satellites, like the Solar Dynamics Observatory, the image appeared like a wound carved into the sun's crown of fire, a yawning black scar across a golden inferno. For many, it sparked fear. Is the sun dying? Some whispered online. Others went further, calling it a gateway to another dimension or even a cosmic warning sign. That's the thing about space discoveries. They tug at both your rational mind and your deepest imagination. We want explanations, but we also want myths. And yet, this discovery is neither doomsday nor science fantasy. Instead, it is a chance to understand the sun in a way humans never have before. Because when you look at that hole, you're not seeing weakness, you're seeing energy unleashed. Streams of solar wind pouring out into the solar system, racing at unimaginable speeds, destined to slam into Earth and ripple through our planet's magnetic shield. Now pause for a moment. Imagine standing outside on a calm night, looking up at the aurora, shimmering curtains of green, purple, and red painting the northern skies. Those lights, those silent cosmic dances, are born from the same phenomenon that creates the holes in the sun's atmosphere. What looks like emptiness is actually power, invisible yet real, reaching across 93 million miles to touch your world. Doesn't it make you feel small but also strangely connected? As if the sun is not some distant fireball, but a living neighbor, one that breathes storms and whispers across space, one that can stir the skies of Earth with its moods. And that is why this discovery matters. Not because the sun is falling apart, but because we're finally learning its language. We're finally noticing the subtle signs of its heartbeat. For the first time in history, we're not just gazing at the sun in awe, we're listening to it. But here's where the emotional twist comes in. Humanity has always placed the sun at the center of its stories. Ancient Egyptians worshipped it as the god Ra. The Aztecs believed the sun demanded sacrifice to keep shining. Even in medieval Europe, people whispered that eclipses were omens of doom. For millennia, the sun was eternal, untouchable, a perfect flame in the heavens. And now, NASA is showing us that it isn't perfect at all. It has blemishes, storms, holes, and tempers. It can flare with violent eruptions that hurl more energy in a second than humanity has ever produced in its entire history. It can dim in patches that look like vast shadows across its face. The myth of perfection is gone, replaced with something even more powerful, the truth that the sun is alive. That realization is humbling because you are alive only because it is alive. Every breath you take, every plant that grows, every drop of water that flows on earth, all of it is powered by the sun's energy. And yet, it is not an unchanging God. It is a dynamic star, one among billions, governed by the same laws of physics as everything else in the universe. So when NASA says they found a huge hole in the sun's atmosphere, don't hear it as a threat. Hear it as a revelation. It's proof that we're finally peeling back the mysteries of our star. It's proof that even something as familiar as the morning sun still holds secrets deep enough to astonish us. And it's proof that space is not just out there. It's here, touching your daily life in ways you rarely notice. This is only the beginning, because once you understand what a coronal hole really is, you start to see the chain of consequences it unleashes. From glowing auroras to dangerous geomagnetic storms, from satellite disruptions to whispers about the fragility of modern life. And the story doesn't end there. The sun has been surprising humanity for thousands of years, and with each discovery, we find ourselves both reassured and unsettled. And maybe deep down, that's what makes space so powerful. It reminds you that even in an age of smartphones and instant news, the universe can still shock you. It can still take your breath away. Now, let's step deeper into this story. To really grasp the significance of this discovery, you need to see the sun not as a lifeless ball of fire, but through the eyes of the civilizations that came before us. Because long before NASA spotted a hole in its atmosphere, humans were already writing myths about the sun's wounds, its battles, its mysterious dark spots. And perhaps, in their own poetic way, they weren't so far from the truth. There was only you, standing on the earth, looking up. Imagine yourself thousands of years ago. No screens, no electricity, no noise of engines or glowing city lights. Just open skies stretching endlessly. At dawn, you would watch as a golden fireball rose from the horizon, banishing the cold night, awakening the fields, and pulling shadows away. And every evening, you would watch it slip away again, leaving darkness to rule until it returned. The sun wasn't just a light in the sky back then, it was life itself. Ancient civilizations understood something instinctively. Without the sun, there was no survival, no crops, no warmth, no rhythm of day and night. That is why nearly every culture, no matter how far apart, placed the sun at the center of its mythology. The Egyptians told stories of Ra, the falcon-headed sun god, sailing across the heavens in a golden boat. Each morning, Ra was reborn, and each night he descended into the underworld, battling chaos to rise again. To them, the sun's daily journey wasn't just natural, it was divine. The Aztecs of Mesoamerica believed the sun demanded sacrifice. Human blood, they thought, was the fuel that kept the sun alive and moving across the sky. Without offerings, they feared it would stop, plunging the world into eternal night. As terrifying as that sounds, it reflects a deep truth. People recognized that the sun was fragile in its own way, dependent on forces beyond human control. In Japan, the sun was revered as the goddess Amaterasu, whose light brought order and harmony to the world. Even today, the Japanese flag carries her symbol, a glowing red sun disk. The Incas of South America worshipped Inti, the sun god, and built temples of dazzling gold to honor him. For them, the brilliance of sunlight was not just heat, but a spiritual presence. Everywhere you look in history, the sun was not just a star. It was a god, a protector, a judge, a provider, and sometimes a destroyer. Now think of the irony. Back then, humans imagined the sun as perfect, eternal, flawless. To them, its steady rise and fall was the ultimate proof of order in the universe. They saw no blemishes, no flaws, only a divine sphere of fire too bright to stare at for long. And yet today, with satellites orbiting above Earth, we see something different. We see sunspots, dark blemishes that come and go like cosmic bruises. We see solar flares, eruptions of unimaginable power, and we see coronal holes, vast black regions where the atmosphere thins and vanishes into space. If you could take one of those ancient priests or astronomers and show them NASA's images, what would they think? Would they see it as proof of their old myths, that the sun really does suffer wounds, that it battles darkness each night? Would they call the coronal hole Ra's gateway into the underworld? Or would they collapse in fear, believing the end had come? This is the fascinating part, because even though we now explain the sun in terms of plasma, magnetism, and solar winds, deep down the same awe remains. The ancients saw gods and spirits. You see nuclear fusion and electromagnetic fields. But the feeling, the awe, the shiver of smallness when you realize how dependent you are on that glowing sphere, that hasn't changed. And here's the myth-busting twist. People today often imagine ancient civilizations as wrong about the sun, as if myths were just ignorance. But if you look closely, those stories reveal a profound truth. They knew the sun was alive in some sense. They knew it wasn't static. They knew it had moods, cycles, and power beyond imagination. They simply used the language they had, gods, myths, sacrifice, to express it. Today, when NASA shows you an image of a coronal hole big enough to swallow dozens of Earths, are you really so different? Science gives you explanations, but your first reaction is still primal: fear, wonder, awe. In that moment, you're not so far from the Egyptians, the Aztecs, or the Incas. There's another layer to this story: nostalgia. Imagine standing at Stonehenge thousands of years ago, watching the midsummer sun rise in perfect alignment with those ancient stones. Or picture the ancestral Puebloans carving spiral petroglyphs on canyon walls, marking where sunlight would strike on solstices. These weren't primitive superstitions. They were careful observations, rituals of respect, attempts to track the heartbeat of the sun. Now, fast forward. Today, NASA does the same thing, but with satellites, computers, and mathematical models. They track the sun's heartbeat, measure its cycles, and predict its storms. In a way, our space agencies are simply continuing a tradition that began with people looking up at dawn, whispering prayers, and building monuments of stone. And here's where the emotional twist deepens. For those ancients, the sun was the closest thing to eternity they could imagine. To them, it would never fail. But in your time, you know that even stars die. You know that billions of years from now, the sun will expand into a red giant consuming the earth in its fire. You know that coronal holes, sunspots, and flares are signs of its turbulent, restless nature. Knowledge doesn't always make things less mysterious. Sometimes it makes them even more humbling. So what does this mean for you standing here in the 21st century? It means that when NASA reveals a massive hole in the sun's atmosphere, you're seeing with two sets of eyes. One, the eyes of science, clear, rational, logical. And two, the eyes of myth, filled with awe, with fear, with the ancient recognition that the sun is not just background. It is the central character in your story, the reason you exist at all. The ancients weren't wrong to worship it. They just didn't have the words you have now. And that's why this discovery matters on more than just a scientific level, because it connects you across thousands of years, binding your modern wonder with ancient awe. It reminds you that no matter how much technology advances, you are still a human under the same sky, living by the same star, feeling the same shiver of awe when you realize it isn't eternal, it isn't perfect, and it isn't fully understood. So the next time you hear about a hole in the sun, don't just think about plasma physics. Think about Ra, Amaterasu, Inti, and all the people who looked up before you, weaving stories to make sense of that glowing mystery. Think about how you're part of the same continuum, still learning, still wondering, still humbled by the same star. Because maybe, just maybe, those old myths weren't simply about gods. Maybe they were humanity's first attempt at saying what we still feel today. The sun is alive, and we are forever in its shadow. When you look at the sun, it seems so simple, a blinding golden circle in the sky, too bright to stare at for long. To your eyes, it looks solid, like a perfect glowing sphere. But the truth is, the sun has no surface in the way Earth does. It isn't made of rock or soil. It's made of plasma, a fourth state of matter, where gas is so hot that its atoms split apart and electrons drift free in a sea of charged particles. That's where the mystery begins. Because if the sun is just plasma, how can it have an atmosphere at all? And how can there be holes in it? To answer that, let's peel back the layers of the sun, one by one. Closest to the center lies the core, a furnace of unimaginable heat and pressure where nuclear fusion occurs. Hydrogen atoms smash together to form helium, releasing energy that will eventually travel outward as sunlight. Without this process, life on Earth wouldn't exist. Surrounding the core is the radiative zone, where light bounces around for thousands, even millions of years, slowly working its way outward. Beyond that lies the convective zone, where plasma churns and boils like water in a pot, rising and falling in massive rolling currents. But here's the part that matters most for you: the outer layers, the part we call the sun's atmosphere. It isn't just one layer. It's a complex, multi-layered crown that shapes everything we see and feel from Earth. The lowest layer of this atmosphere is the photosphere. That's the surface of the sun, the glowing disk you see with your eyes. But don't be fooled. This so-called surface is only about 500 kilometers thick. If the sun were a basketball, the photosphere would be thinner than a sheet of paper. Yet it's here that sunspots appear, those dark blemishes caused by twisted magnetic fields. Above the photosphere lies the chromosphere. You can't see it with the naked eye most of the time, but during a total solar eclipse, it appears as a thin reddish rim around the sun. Here, the temperature begins to rise again, an odd reversal because you'd expect things to cool down as you move away from the core. Instead, the chromosphere heats up, reaching tens of thousands of degrees. And above that, stretching millions of kilometers into space, is the corona, the crown of the sun. This is the part that holds the real mystery. It glows faintly, often invisible against the brightness of the sun, but during eclipses or through NASA's instruments, it appears as a vast halo of light. And here's the paradox. While the surface of the sun is about 5,500 degrees Celsius, the corona blazes at over 1,000,000 degrees. How can the outer atmosphere be hotter than the surface below it? To this day, scientists don't fully know. It is in this corona that coronal holes appear, regions where the plasma thins, where the magnetic field opens outward, creating dark patches when viewed in ultraviolet light. These are the holes in the sun's atmosphere that NASA reports. They aren't holes in the sense of emptiness, but they look like voids, great dark patches spreading across the sun's glowing crown. Think of it like this. If the corona is the sun's flowing hair, then a coronal hole is like a sudden parting in that hair, revealing the space beneath. Through those gaps, charged particles escape more easily, racing into the solar system as high-speed solar wind. And here's where the emotional twist comes in. For centuries, humans imagined the sun as flawless, a perfect disk. Even when Galileo first pointed a telescope toward it in the early 1600s and saw sunspots, the discovery shocked people. How could the sun, eternal divine, have blemishes? Now imagine their reaction if they could see today's images from NASA's Solar Dynamics Observatory or SOHO spacecraft, showing not just spots, but vast, gaping black scars across its glowing face. To the ancients, it would have looked like the sun itself was wounded. To you, it looks unsettling, like a reminder that even the most reliable force in your life has turbulence, fragility, and mystery. But instead of fear, there is wonder, because what you're really seeing is not weakness, but dynamism. The sun's atmosphere isn't a calm shell of gas. It's alive, constantly shifting under the influence of magnetism. When the magnetic field lines loop and twist, they trap plasma, forming bright arcs. When those lines break open, plasma escapes, forming holes. It's not a flaw in the sun, it's its heartbeat. And that heartbeat doesn't just stay in space, it touches Earth. When coronal holes open, streams of solar wind rush out, carrying charged particles across the solar system. Days later, they reach Earth, slamming into its magnetic field. Sometimes the result is beautiful, dancing auroras in green, purple, and red. Other times, it's dangerous, geomagnetic storms that disrupt satellites, interfere with GPS signals, or even knock out power grids. That's why understanding the sun's atmosphere matters, because the corona, with its strange, unpredictable holes, is not just out there. It's part of your daily life, affecting everything from your smartphone to airline flights to the electricity in your home. Here's the myth busting moment: a hole in the sun's atmosphere is not the beginning of the end. It isn't a tear, a collapse, or a sign the sun is dying. It's a natural, recurring feature of solar activity. Coronal holes appear more often during certain parts of the sun's 11-year cycle, and while they look alarming, they're simply a reminder of how complex and powerful our star truly is. So the next time you hear that NASA has spotted a massive hole in the sun, don't imagine a cosmic disaster movie. Imagine instead that you're peeking into the sun's crown, watching energy flow out into space, connecting your world to the star that sustains it. When you step outside tomorrow morning and feel the warmth of sunlight on your face, remember this: you are standing under the glow of a star that is anything but simple. Beneath that perfect disk lies a storm, a mystery, and a crown full of secrets. And those holes? They are not signs of weakness. They are windows into the hidden heartbeat of the sun. And now that you know what the sun's atmosphere really is, it's time to travel back to the first moment humans realized something strange was happening up there. Because NASA may have the latest satellites, but the first discovery of a coronal hole goes back to the very beginnings of space exploration. It was the 1970s. Humanity had just taken its first steps onto the moon. Skylab, America's first space station, floated high above Earth, carrying astronauts and instruments designed not just to study our planet, but to turn their gaze outward toward the sun. For most of human history, you could only look at the sun with your eyes, shielded by smoke, glass, or sheer courage. Telescopes revealed spots and flares, but the finer details remained hidden by its overwhelming brightness. Skylab changed that. For the first time, we had the technology to observe the sun continuously, in wavelengths invisible to human eyes. And what those instruments saw was astonishing. Astronomers were scanning the sun's corona in ultraviolet light when they noticed something that didn't make sense. Instead of a uniform glow, huge dark patches stretched across the crown of the sun, like shadows painted on its fiery halo. These weren't sunspots on the surface. They were vast regions in the outer atmosphere where the brightness dimmed dramatically. At first, some wondered if it was an error: faulty equipment, interference, a trick of light. After all, the sun wasn't supposed to have holes. But the data was clear. Something very real was happening. These dark regions were larger than Earth, sometimes stretching over a quarter of the sun's surface. And they weren't static. They shifted, grew, and vanished over days or weeks. NASA gave them a name: coronal holes. You have to imagine the shock of those first scientists. For centuries, people had seen the sun as flawless, eternal. Even in the scientific age, astronomers thought they were building toward a neat, predictable model of the sun's behavior. And suddenly, Skylab was telling them, the sun's atmosphere has gaps, openings, and mysteries we never expected. It was humbling, it was unsettling, and it was thrilling. Because with every new discovery, the sun became not smaller in our imagination, but greater, stranger, more alive, more complex than anyone had thought. But what made these holes so important wasn't just how they looked, it was what they did. During Skylab's solar missions, scientists noticed that streams of high-speed particles were flowing from the direction of these dark patches. Instruments on Earth confirmed that when a coronal hole faced our planet, bursts of solar wind slammed into Earth's magnetic field. This wasn't coincidence, it was a direct connection. For the first time, humanity understood that coronal holes weren't just curiosities on the sun, they were active players in shaping space weather. They could send ripples of energy racing across the solar system, strong enough to affect technology, power grids, and even the safety of astronauts in orbit. Think about the perspective shift that required. Until then, the sun had been seen mostly as a source of light and heat. Suddenly, it was also a storm generator, its moods capable of reaching across 93 million miles to rattle our world. Here's the emotional twist. Imagine being an ordinary person in the 1970s, hearing the news that NASA had found holes in the sun. You just watched humans land on the moon. You lived in an era buzzing with Cold War fears, nuclear tests, and uncertainty about the future. And now, the very star that gave you life was suddenly being described as full of gaps, shadows, and invisible winds. For some, it must have felt like a cosmic omen. For others, it was a thrill, a new frontier of science opening right above their heads. But most people, as always, didn't notice. The discovery of coronal holes didn't dominate headlines. It wasn't a moon landing or a Mars rover. It was quiet science, careful observations, data trickling in from a lonely station drifting high above Earth. The story of the sun's holes was, in a sense, too subtle for its time. It would take decades and much more dramatic images from newer satellites for the public to truly pay attention. Still, for scientists, Skylab's observations were groundbreaking. They confirmed a deep truth. The sun is not a static ball of fire. It is magnetic, turbulent, and unpredictable. Its atmosphere is not a calm blanket of gas, but a restless, boiling crown. And through its coronal holes, it speaks directly to Earth. This was the beginning of a new field, space weather science. Just as meteorologists study Earth's skies to predict storms and protect cities, scientists realized they would need to study the sun storms to protect satellites, power grids, and astronauts. Coronal holes became a key puzzle piece in this effort. Each one was a doorway, a channel which the sun's invisible breath could surge outward and sweep across the solar system. Here's the myth-busting moment. People sometimes imagine that NASA just discovered coronal holes in recent years. In reality, scientists have been studying them for half a century. What's changed isn't the discovery, it's the clarity. Back in the 1970s, Skylab's images were grainy, fuzzy, sometimes hard to interpret. Today, satellites like the Solar Dynamics Observatory, SDO, give us high-definition views of the sun in stunning detail, showing holes so vast they make Earth look like a marble. And that's the shock factor. They're not rare, tiny anomalies. Sometimes they cover nearly a quarter of the sun's surface. Imagine looking at the sun, and seeing a gaping black wound across its glowing face, dark, yawning, endless. That's the reality satellites now reveal. Looking back, Skylab's discovery feels like a foreshadowing, a quiet hint of the stormy revelations to come. Because while coronal holes are fascinating in their own right, they're only one part of the sun's story. As scientists dug deeper, they realized that the sun isn't just capable of sending gentle winds. It can unleash flares and eruptions powerful enough to knock out technology worldwide. But before we get to those storms, let's pause on this thought. The very first time humanity truly noticed a coronal hole, it was looking through a space station that has long since fallen back to Earth. Skylab burned up in 1979, scattering fragments into the Indian Ocean and Australia. But the knowledge it gave us lives on. It was a reminder that even our greatest achievements, rockets, stations, empires, are temporary. But the sun, restless and alive, will continue speaking, and through its holes it whispers truths we're only just beginning to hear. So the first time NASA noticed something strange, it wasn't a warning of doom. It was an invitation. an invitation to stop thinking of the sun as a background light and to start seeing it as a dynamic neighbor, a star with secrets. And as technology advanced, that invitation would be accepted again and again, with each new spacecraft revealing just how dramatic, how vast, and how humbling those secrets really are. You might be tempted at first to imagine it as something frightening, a hole in the sun like a great cosmic wound burning deeper into its surface, threatening to tear it apart. But that's where the myth begins, and where the science surprises you. A coronal hole is not really a hole in the way you think. Nothing is physically missing. No chunk of the sun has been ripped away. Instead, it's a region in the sun's outer atmosphere, the corona, where the magnetic field lines open up, stretching far out into space instead of looping back into the star itself. Imagine a forest of invisible wires. Some twist and tangle, curling back into knots. Others stretch endlessly outward, straight as arrows. These open lines create pathways, escape routes for particles inside the sun. And when they escape, they do so as the solar wind, a fast, steady stream of charged particles that pours out of these coronal holes at incredible speeds, sometimes as fast as 3 million kilometers per hour, invisible to your eyes, but very real to your world. Seen through NASA's Solar Dynamics Observatory, these holes appear like great dark patches smeared across the glowing disk. They aren't actually cooler than their surroundings, though they do have lower densities, which makes them seem darker in extreme ultraviolet images. That's why they appear almost ominous, as if someone has dipped a brush in black ink and dragged it across the face of the sun. And here's where the twist comes in. These holes can be absolutely enormous. Sometimes they stretch across a quarter of the sun's entire surface, wide enough to swallow dozens of Earth's whole. You can't help but shiver when you realize how small and fragile our planet is compared to these gaping dark expanses. But here's the myth-busting truth. They are not signs of danger for the sun. Quite the opposite. Coronal holes are part of the sun's natural rhythm. They come and go in sync with its 11-year solar cycle, appearing more often during periods of low solar activity and shrinking when the sun grows more active. They are not tears. They are not wounds. They are reminders that our star is dynamic, restless, and alive. And while the sun itself doesn't suffer from them, Earth does feel their breath. Every time a coronal hole points directly at our planet, its solar wind rushes toward us, reaching Earth in just a few days. Sometimes it passes with a whisper, tickling the atmosphere, painting soft auroras across the polar skies. Other times it crashes like a storm, battering satellites, disrupting GPS systems, and even threatening power grids. Here lies the emotional twist. The same holes that terrify us also give us beauty. The same invisible streams that could knock out communication networks are the very forces that light up the skies with auroras, dancing ribbons of green, purple, and red. Danger and wonder, tied together in one breath of solar wind. And so you begin to realize these coronal holes are not flaws in the sun. They are windows. Windows through which the sun exhales its breath into space, reminding you that even a star, mighty, eternal, and blinding, is not still. It moves, shifts, pulses. It lives. But what happens when that breath grows violent? What happens when a hole grows larger than usual, when its winds strike Earth harder than expected? That's when the sun's hidden storms show their full power, and history gives us haunting reminders of what those storms can do. You wake up one morning and the headline feels almost unreal. NASA has discovered a huge hole in the sun's atmosphere. For a moment, you freeze. A hole in the sun? The star that fuels life? The very heart of our solar system. The eternal flame that ancient civilizations worshipped as a god. How could it possibly have a hole? Isn't the sun solid, unbreakable, everlasting? For thousands of years, humanity has believed it to be untouchable. And yet, here you are, staring at the words that make your chest tighten. Your first thought might be panic. If there's a hole in the sun, doesn't that mean something catastrophic is about to happen? Could the sun collapse like a dying star? Could Earth's fragile balance be destroyed in an instant? Or worse, could this be the beginning of a cosmic chain reaction, a ripple that will change life forever? But here's the twist. This isn't science fiction. This is science fact. NASA's satellites, orbiting silently in the cold darkness of space, captured it first. A gaping region in the sun's corona, the outer atmosphere, that looked like a shadow tearing through fire. Imagine a black wound against a burning sea of gold. It wasn't a small dent. It wasn't a flicker. It was enormous, large enough to swallow dozens of Earths inside it. A cosmic canyon carved into the sun's glowing skin. And that's where the story begins. Terrifying, might not be what you think. At this point, you might feel the myths rising in your mind. Haven't we always imagined the sun as a ball of fire? Haven't movies taught us that if the sun weakens, Earth will freeze, civilizations will collapse, and everything we know will be lost? But here's the truth. You've been misled. The sun is not a ball of fire, and a hole in its atmosphere is not the same as a hole in your roof, leaking disaster into your home. Still, it's no small matter. This hole, officially known as a coronal hole, is a place where the sun's magnetic field opens up, releasing streams of charged particles that pour into space like invisible winds. These winds race toward Earth, and when they arrive, they can stir our magnetic shield, paint our skies with auroras, and sometimes, if they're strong enough, disrupt satellites, power grids, and the very technology our modern lives depend on. So yes, it's beautiful. And yes, it's dangerous. And suddenly you feel it. The paradox. The same hole that looks like a wound in the sun's glowing face is also a window into understanding one of the greatest mysteries of the cosmos. Think about it. The sun has burned for 4.6 billion years. It has seen Earth form, oceans boil, life crawl out of the sea, civilizations rise and fall. The pyramids of Egypt, the temples of the Maya, the Viking ships crossing stormy seas, every one of them looked up at the same sun, never imagining it could bleed shadows into space. Yet now, for the first time in history, we can witness this hidden truth with our own eyes, and that realization shakes you. Because here's the emotional twist. The sun is not eternal. It is alive. It breathes. It pulses. It changes. It hides secrets behind its light, and these holes are like whispers, reminders that even the greatest star we know is fragile, dynamic, and evolving. NASA's announcement wasn't just a press release. It was a moment that forced humanity to look again at what we thought we knew, to question myths that have lived for thousands of years, to admit that the sun isn't invincible, and neither are we. Now imagine this. Streams of solar wind flowing through that hole, racing across 93 million miles of empty space, finally crashing into Earth's atmosphere. Invisible, silent, unstoppable. You wouldn't hear it. You wouldn't feel it. And yet the lights in your city could flicker. Satellites guiding planes could glitch, your GPS could fail, the phone in your hand, the electricity humming through your home, even the banking systems that run the global economy, all of it could shudder from a force born inside that cosmic wound. And still, most people won't notice. They'll go about their day, sipping coffee, scrolling through headlines, unaware that their lives are tethered to the moods of a star. But you now know. This is not just about a hole in the sun. It's about perspective. It's about realizing that space is not empty. It's alive, in motion, always reaching for us. The sun is not a distant object. It's a neighbor, a guardian, a wild force that touches you every single second of your life. And when it shows us a hole, it's not a sign of collapse. It's a reminder of connection. Still, questions linger. If this hole is natural, why did it appear now? Why does it grow so large that even scientists were stunned? What does it mean for Earth in the long run? And this is the question that might keep you awake tonight. What if one day the sun does something far more violent? What if this hole is just a hint of a greater storm waiting to come? NASA calls it a discovery. You might feel it as a warning. And as the story unfolds, You're about to see why this hole in the sun's atmosphere is not just a scientific headline, it's a cosmic wake-up call. When you hear the word sun, what image appears in your mind? Maybe it's a blazing ball of fire, maybe it's a giant torch burning endlessly in space, or maybe it's that golden disk that rises and sets, reliable, eternal, the rhythm keeper of your days. But here's the truth most people never realize. The sun is not a ball of fire at all, and it's certainly not burning the way a campfire burns on Earth. This is where myth meets science. For thousands of years, human cultures imagined the sun as a flame. The Greeks thought it was a chariot of fire pulled across the sky by Apollo. The Egyptians worshipped Ra, the fiery god whose eye lit the heavens. Even today, school books sometimes call it a ball of burning gas. But scientifically, that's misleading. The sun is not fire, it is fusion. Deep in its heart, 150 times denser than steel, temperatures soar to over 27 million degrees Fahrenheit. At that core, hydrogen atoms are squeezed so tightly that they fuse together, transforming into helium. That fusion releases unimaginable energy, light, heat, radiation, that takes thousands of years to journey from the core to the surface, and then just 8 minutes to cross the vacuum of space to touch your skin. So the sunlight you feel today, it began as atomic reactions long before humans existed. The warmth on your face might have started its journey when woolly mammoths still roamed the earth. That's how deep, how ancient, how powerful the sun's story is. Now imagine this living machine. It has layers, each stranger than the last. The core, the engine room of nuclear fusion. The radiative zone, where light takes a slow, staggering walk, bouncing for thousands of years before moving on. The convective zone, where plasma churns like boiling water. The photosphere, the surface we actually see, a glowing sea of light. The chromosphere, a thin reddish glow. And finally, the corona, the sun's atmosphere stretching millions of miles into space. It's in this outermost layer, the corona, that NASA spotted the hole. And here comes the twist. The corona is hotter than the surface. Think about that. If you stand near a fire, the closer you are, the hotter it feels. But the sun flips this logic upside down. The surface is about 10,000 degrees Fahrenheit, while the corona blazes at over 1,000,000 degrees. How? Scientists are still unraveling the puzzle, and these coronal holes might be part of the answer. That hole you saw in headlines, it isn't an empty space carved out of the sun. It's an opening in the magnetic field, like a crack in a shield where charged particles can escape. Picture steam venting from a kettle, but instead of steam, it's high-energy solar wind. Instead of filling your kitchen, it fills the solar system. And that wind, it's racing toward you right now. Invisible, silent, but powerful enough to shape Earth's magnetic poles, to trigger dazzling auroras, to interfere with satellites orbiting above your head. Without these winds, the universe would look different. With them, life on Earth is constantly reminded that it exists in the path of a restless star. But here's the part that grips you emotionally. Humanity has always misunderstood the sun because we only saw its surface. You were taught to think of it as a solid disk in the sky. Yet in truth, it's alive with motion, magnetic fields twisting like serpents, storms erupting larger than Earth itself, and yes, holes opening in its glowing atmosphere. What looks eternal from a distance is, up close, chaotic and fragile. And isn't that a reflection of life itself? From afar, your routines, your days might seem steady. But beneath the surface, everything is in motion, everything is shifting, everything is changing. The sun reminds you that stability is often just the illusion of distance. Now go back to that hole NASA revealed. Imagine standing on Earth thousands of years ago. No satellites, no telescopes, no scientific instruments, just your eyes, the blue sky, and the golden orb above. Could you ever have imagined that inside that perfect light there are layers, storms, winds, and wounds? Could you ever have believed that something as mighty as the sun could open up and release a torrent of energy? It almost feels like myth again. And yet this time, it's truth. Here's the emotional twist. The sun is not infinite. It will not shine forever. Billions of years from now, it will run out of fuel, swell into a red giant, and eventually collapse into a white dwarf, leaving behind only memory and dust. But long before that distant ending, it will continue to pulse, breathe, and reveal secrets through these coronal holes. Each hole is a glimpse into the mechanics of a star's heartbeat. And for you, standing here in the 21st century, this moment is special. You're alive at a time when humanity can finally see what ancient people could only imagine. You're part of the first generation to witness the sun not as a flat disk, but as a living, breathing giant with scars and mysteries. So the next time someone says, the sun is just a ball of fire, you'll know better. You'll know it's a nuclear furnace wrapped in plasma, crowned by a 1,000,000-degree atmosphere and pierced by vast magnetic wounds we call coronal holes. You'll know that what looks like a simple light in the sky is actually a universe of activity, spilling energy into every corner of our solar system. And you'll know that NASA's discovery wasn't just science. It was a myth, shattered. Because sometimes the most powerful truth is this: the things you think you understand the most are often the ones you know the least. And that's where the story deepens. Because if the sun is so much stranger than you imagined, then what does this hole truly mean for Earth and for your future? Close your eyes for a moment and imagine yourself standing in the desert of ancient Egypt, 3,000 years ago. The sand burns under your feet. The Nile glitters in the distance. Above you, the sun blazes in all its glory. To you, it is not just light, it is a god. It is Ra, the giver of life, the one who sees all. Every sunrise is rebirth, every sunset a journey into the underworld. The sun is eternal, divine, untouchable. Now shift. You are in Greece, centuries later. The sun is Helios, a radiant charioteer steering a golden carriage across the heavens. His horses gallop through the sky, carrying day after day into the world. You don't question how the light arrives. You explain it with stories, with myth, with imagination. But what happens when something interrupts that perfect light? Picture the same people, the same ancient worlds, but this time the sun is swallowed, an eclipse. Imagine the terror. Day turns to night in an instant. Birds stop singing. Shadows stretch unnaturally. To the unprepared, it feels like the end of the world. Ancient Chinese texts describe dragons devouring the sun. In Viking lore, wolves chased and consumed it. For centuries, eclipses were seen as omens, warnings from the cosmos itself. And isn't that interesting? Every time the sun revealed a crack in its perfection, whether through an eclipse, a sunspot, or a flare, humanity's instinct was awe, fear, and myth. Fast forward to 1610. You're standing beside Galileo Galilei, peering through one of the first telescopes ever pointed at the sky. What do you see? Dark blotches on the sun's surface. Sunspots. Imperfections on what was once thought flawless. Galileo's discovery shook the world, not just scientifically, but spiritually. If the sun could be blemished, could anything in the heavens be truly perfect? That same question echoes now, centuries later, as NASA reveals holes in the sun's atmosphere. Once again, what was believed eternal shows itself to be dynamic, fragile, and imperfect. But unlike ancient times, you now have the science to understand it, and yet the emotional reaction is not so different. Fear, wonder, curiosity. Think of the Mayans, who built temples aligned with solar patterns, timing rituals to the sun's movements. Think of Stonehenge in England, where massive stones mark the solstices. Think of farmers across every civilization, planting and harvesting by the light of the sun, their survival tied to its rhythms. Now think of yourself today. You wake with alarms, not sunrises. You measure time with clocks, not shadows. And yet, your life is still governed by the sun, by its warmth, by the seasons, by the invisible energy flowing through its atmosphere, now revealed in the form of coronal holes. Here's the myth-busting truth. The sun has never been perfect. It has always been restless. The ancient myths of dragons, wolves, and gods weren't entirely wrong. They were metaphors for something very real. The sun does vanish in eclipses. It does roar with storms. It does bleed shadowy wounds across its glowing surface. And today, satellites give you the language to describe what Galileo could only glimpse: magnetic fields, plasma, solar winds. But deep down, the feeling is timeless. You are still that ancient human, looking up in awe, wondering if the sun's change is a message meant for you. Now consider this. For thousands of years, humanity had no idea what the sun truly was. No one knew about fusion. No one understood radiation. No one could have imagined a hole in its atmosphere stretching larger than Earth itself. But now you live in the only age where you can see it, measure it, predict it. And that realization is almost spiritual. It's as if, across centuries of myths, sacrifices, prayers, and questions, humanity has finally been granted a glimpse behind the curtain. And what you find there isn't a god, but something perhaps even more miraculous: a natural machine so complex and alive that it creates life itself. Think of the irony. Ancient people feared that a hole in the sun would mean the end of the world. But today, NASA reveals such a hole not as an omen of doom, but as a doorway to understanding. And yet, the emotional shiver is the same. When you hear the words "huge hole in the sun's atmosphere," your pulse quickens. You imagine collapse. You imagine fire raining down. You imagine life flickering out like a candle. The human brain, wired for story, still responds the way it did thousands of years ago. But science asks you to look again, to see beyond fear, to find meaning not in myths, but in mechanisms. And here's the twist. Sometimes the truth is even more awe-inspiring than the myth, because instead of dragons swallowing the sun, you discover magnetic fields unraveling. Instead of gods punishing mortals, you uncover streams of charged particles dancing across space. Instead of fear, you find wonder. Now picture yourself thousands of years from now. What new mysteries will the sun reveal? Will future civilizations laugh at our limited understanding the way we smile at ancient myths? Will they find new holes, new storms, new secrets hidden in its light? The story of the sun is not finished. And this discovery, the hole NASA has revealed, is just one chapter in a saga that has been unfolding since the first humans tilted their heads to the sky. But here's the emotional twist you can't ignore. While the sun's mysteries inspire awe, they also hold consequences. These holes, these winds, these storms, they touch your life in ways you might never have imagined. And as you'll soon see, what feels like a distant curiosity in space might be the very force shaping your future here on Earth. You're standing outside on a calm evening. The sky is clear, the stars twinkle faintly, and the air feels still. Nothing seems unusual. But above your head, 93 million miles away, the sun has just released a stream of invisible energy pouring through that vast coronal hole. Like a silent tide, solar wind surges into space, racing faster than 1,000,000 miles per hour. And whether you realize it or not, Earth is in its path. This is where awe turns into urgency. Because when those charged particles collide with Earth's magnetic field, they don't simply vanish. They ripple. They stir. They rattle the invisible shield that has protected our planet for billions of years. That shield, the magnetosphere, is the reason you have an atmosphere, the reason oceans don't boil into space, the reason life itself can exist here. But when solar winds slam into it, something astonishing happens. First, the beautiful part, auroras. Curtains of green, purple, and red light shimmer across polar skies as if the heavens themselves are alive. Ancient people thought they were messages from the gods. Today you know they are the footprints of solar storms, painting the sky as energy funnels into Earth's atmosphere. If you've ever seen them, you know how humbling it feels, like the universe is reminding you of your smallness. But here comes the darker side. That same energy can also disrupt. Satellites orbiting Earth begin to shudder. Their electronics, built with precision, can glitch under the onslaught. GPS systems, the invisible guides behind planes, ships, and even your phone can drift. Communications may fail. In 1989, a powerful solar storm knocked out Quebec's entire power grid in 90 seconds, plunging millions into darkness. Imagine that happening today in a world more dependent on electricity than ever. It's not just power, banking networks, air traffic, internet cables, all of it fragile against the breath of a star. And here's the emotional twist. All of this chaos begins in a place that looks like nothing more than a shadow on the sun's glowing face. A hole, a silent, dark gap. NASA calls them coronal holes, but you might call them cosmic reminders, proof that the sun is not distant. It reaches you every day, not just with light and warmth, but with energy that can either paint the sky or disrupt your civilization. Now pause and think, how many people around you even know this? Most walk through their lives never realizing that the aurora borealis is a storm, that the lights in their home are connected to the moods of a star, that a single coronal hole could shake the very infrastructure of modern life. And yet, you know, here's where science takes it further. These solar winds are not random. They follow patterns, cycles. Every 11 years, the sun goes through a solar maximum, a peak in activity where coronal holes, flares, and storms become more common. Right now, we are approaching another peak. That means the hole NASA discovered isn't just a curiosity, it's part of a rising storm cycle, one that could bring both beauty and danger to your skies. And the timing couldn't be more important, because your world today is fragile in ways it has never been before. In Galileo's time, a solar storm might have gone unnoticed, maybe causing strange lights in the sky. But in your time, with billions of devices, satellites, and networks, a single storm can ripple through economies, governments, and lives. NASA calls this space weather. And make no mistake, it is as real and impactful as a hurricane or an earthquake. The only difference? Most people don't even know it's happening. And this leads to a shocking thought. What if a storm big enough struck tomorrow? Scientists know it has happened before. In 1859, a solar storm known as the Carrington event sent electric currents racing through telegraph wires, shocking operators and setting papers on fire. Back then, technology was primitive. Imagine that same storm today. Power grids fried, internet cables disrupted, satellites destroyed. A blackout not for hours, but for months. Some experts warn it could cost trillions and take years to recover. And all of it from a hole in the sun's atmosphere. That's where the emotional twist grips you. What seems distant, abstract, almost poetic can become frighteningly real. The sun is not a background object in the sky. It is an active player in your story, shaping your present and future in ways you can't afford to ignore. But here's the hope. The same discovery that shocks you also protects you. By finding these holes, by studying their patterns, NASA and other space agencies are learning to forecast solar storms the way we forecast hurricanes. They can warn power companies, they can prepare satellites, they can help humanity brace for what's coming. And in that sense, the hole in the sun is not just a threat, it is a gift. It is knowledge. It is foresight. Because when you understand the sun, you understand the forces that have always ruled your world. Forces that ancient myths tried to capture, forces that science now names and measures, forces that still, even with all our knowledge, inspire both awe and fear. So next time you see an aurora or hear about a solar storm or read that NASA has found a massive hole in the sun, remember this: you are living inside the weather of a star. And that weather can both dazzle you and humble you. And that is where the story deepens. Because if the sun's holes can reach across millions of miles to touch Earth's technology, what does that say about the delicate balance of life itself? You step outside and the warmth of the sun touches your skin. It feels simple, almost ordinary. But here's the secret. That warmth isn't just comfort, it's destiny. It's the architect of every ocean, every forest, every breath you've ever taken. Without the sun, Earth is just a frozen rock drifting in darkness. With it, life not only survives, it thrives. But the sun has never been constant. And that is where the story takes a surprising turn. Billions of years ago, the sun was weaker. Scientists call it the faint young sun paradox. The early sun was only about 70% as bright as it is now. If that were the case today, Earth should have been an ice ball. Yet somehow, liquid water existed. Somehow, life found a foothold. Was it greenhouse gases trapping heat? Was it a thicker atmosphere? The details are still debated, but one truth remains clear. From the beginning, Earth's fate has been tied to the moods of its star. Now fast forward. Over eons, the sun brightened. It pulsed. It erupted. It poured solar winds into space, stripping atmospheres from planets like Mars, reshaping the destinies of entire worlds. Mars may once have had rivers, lakes, maybe even oceans, but without a strong magnetic shield like Earth's, the sun's energy tore its atmosphere away, leaving behind the cold desert you see today. And here's the haunting thought. What happened to Mars could happen to Earth, if not for that invisible magnetic cocoon protecting you. Every coronal hole, every stream of solar wind tests that shield, and every time Earth holds. But the scars remain, written in the layers of history. You can see it in ice cores pulled from Antarctica. Trapped inside those frozen cylinders are chemical fingerprints, tiny spikes of radioactive isotopes that reveal past solar storms. Scientists can trace solar activity back thousands of years, linking bursts of the sun's energy to shifts in climate, even to disruptions in ancient societies. Think of the Maunder Minimum, a period in the 1600s when sunspots nearly vanished. The sun grew strangely quiet, and during that time, Earth slipped into what's called the Little Ice Age. Rivers in Europe froze solid, crops failed, societies struggled, all because the sun's heartbeat changed. Now pause and feel the weight of that truth. The sun doesn't just light your world, it shapes its very rhythm, its seasons, its cycles of abundance and struggle. And when NASA points to a hole in the sun's atmosphere, you're not just looking at space weather, you're glimpsing the hand that has always painted Earth's story. Here's the twist that grips your emotions. Every creature that has ever lived owes its existence to the sun's restless balance. Dinosaurs walked under its warmth, mammoths grazed in its glow. Your ancestors hunted, farmed, built cities, all beneath the same star with its moods quietly guiding the course of history. And today, you still live at its mercy. Climate, crops, energy, all of it tied to the invisible breath of a star. The hole NASA found is just one moment in a vast symphony, one note in a song billions of years old. But that one note matters because it reminds you of the fragility of balance. Think of Earth as a ship sailing through a cosmic ocean. The sun is both the wind in your sails and the storms that threaten to sink you. Too little energy and you freeze, too much and you burn. And every time a hole opens in the sun's atmosphere, that balance shifts, sometimes gently, sometimes violently. Now consider this myth-busting fact. The sun doesn't orbit Earth. You orbit it. You are the dependent one. Everything you do, every light switch you flip, every meal you eat, every step you take is powered by a star that doesn't even know you exist. And yet, when it hiccups, when a hole appears in its atmosphere, your entire world feels it. Here's the emotional twist. Humanity has always thought of itself as powerful, as in control. But the sun reminds you that your greatest achievements, skyscrapers, satellites, the internet, are fragile compared to the whims of a star. The hole in the sun is like a whisper, a reminder. You live because I allow it. And yet, instead of fear, there is awe. Because what a gift it is to live in this delicate window where the sun is stable enough to nurture life, dynamic enough to inspire wonder, and mysterious enough to keep you questioning. Now ask yourself, how many other civilizations might have looked up at their own stars, wondering the same? How many worlds never got this chance, their suns too violent or too weak to sustain life? How rare, how precious that you are here, on this world, with this star, in this moment of cosmic history. The hole NASA discovered is not just a scientific detail, it's a reminder that the sun is alive, shaping you even as you breathe. And it's a warning. Pay attention. The same force that nurtures you can also test you. Because as the story of Earth proves, the sun is not a background light, it is the author of destiny. And this hole, it may be the sun's way of reminding you that the story is still being written.